Welcome to part 3 on the recursion video series. Today we'll be looking how to solve binary search recursively. You can solve binary search both iteratively and recursively, but to understand recursion, today we'll be solving it recursively. I have another video in the description below where I go into more details of binary search. But in today's video, I'll be just focusing mostly on the recursive part. I'll be briefly touching how the binary search works, and then we'll look at the recursive code and we'll look at the stack frame. So this is the main part I wanted to focus on today, how the stack frames work when it comes to binary search. Because going forward, you'll see for almost every recursive problem you solve, you need to be able to think in terms of stack frames. That makes thinking of the recursive solution much easier. So let's get started. So today what we're going to do is we want to find if 12 exists or not in an array that's passed into us. And not just 12, any number that will be passed in an array and a number, and we have to check whether it exists or not. And if it doesn't exist, we'll return a -1. If it exists, we'll return the index of that item. So the way binary search works, again, in the description below there's more details to the binary search, but in this we won't be going to too many details. So the way binary search works is you'll have a beginning pointer and an end pointer. That's how your binary search starts. Then you look at the mid item, which is 3 here, and you see whether this is the item you're looking for. So 12 is bigger than 5, so I know the item I'm looking for is on the right side. So since initially my pointers were here, since I know it's on the right side, the beginning pointer will move here. Now again I do the same thing, pick the mid index, which is 5, and I check whether it's the number I'm looking for. No, the number I'm looking for is bigger than this. So again, my beginning pointer, I'll move to the right of the last index I checked, which is here. So beginning and end pointer, again check whether, in this case, when I do mid, it will come up to this index, which is 6 plus 7 divided by 2. If you round it out, it will be 6. Again, is this the number I'm looking for? Yes. In that case, I'll return 6. And if this was not the number I'm looking for, you again move the pointers, but either your end pointer moves to the right or your beginning pointer moves to the left. At some point, if the number you're looking for is not found, they cross each other. So if those beginning and end index cross each other, which means if begin index is greater than end index, at that point you know that the item doesn't exist and you return a -1. In this case, we found it, so we will return index 6. So the way this works, this is the Java code for it. I haven't put the main method. The main method will pass in an int array and the find me. So int array will be this, find me is 12. And from here, what I'll do is I'll call a helper method. So the helper method, there's 2 additional parameters. I pass the array, find me. I also pass the beginning index and the ending index, which is this and this. So when you come here, now this is where the recursion happens. When you come here, so for any recursion based problems, you will have a base case. In this case, there are 2 base cases, yeah, but you'll have 1 or more base cases. Base case is where your recursion finally ends, because you'll call itself, it will call itself, and then as it keeps calling itself, finally a base case will be reached. That's when it returns. So in this case, there are 2 base cases. One is if your start index has gone over the end index, which means like you're looking like this, move start index, move end index, move start index, move end index, move start index, or if you move end index, either way if they cross each other, means you haven't found the item you're looking for. So if start index is greater than end index, you return -1. So that is one base case. Another base case is what happened earlier, where you actually do find it. So you keep looking, at some point the mid index, sorry, I think I missed a square bracket here. Yeah, so the item at the mid index is equal to the item you're looking for. In that case, you return the mid index. So this is a success base case, this is a failure base case. So these are the 2 base cases, but if you don't meet either of these 2 base cases, you come into this part. So what I put in the green box is basically the recursive part of the code. So what you're saying is, when I come to this part, the number I'm looking for is that bigger than the mid? So say when we started here, this and this, your mid index is this. Is the number I'm looking for 12 bigger than 5? Yes. So it will come here, and in which case you are saying use the same array, use the same find me, but the start index you modify it. So initially your start index was here, where this finger is left at 0. But when you see that the number you're looking for is to the right of this thing, you move the start index to mid index plus 1. Mid index plus 1 and end index remains the same. Now suppose, however, the number you are looking for is less than this. In that case, you keep the start index the same. You move the end index to mid index minus 1. So you eliminate mid index. So in this case, if find me is greater, you go right, where end index remains the same, start is mid plus 1. But if it's lesser, if the number you're looking for is to the left, then you keep the start index the same, but the ending index you move before mid index minus 1. So it comes here, it does some work, comes here, and at some point it finds it and it returns, and when it returns, it comes to the previous call. From there it returns, comes to the previous call. So like I said earlier, it's much easier to understand recursive problems if you understand them in terms of stack frame. Because when you do in stack frame, you isolate one part of the problem and you don't have to think of the rest of it. You can just think of that part of the problem and then the next stack frame, and that's basically divide and conquer. It's much easier to understand that way. So let's look at how the stack frames work from the beginning. So if you saw my previous video, I had said that when a method is called, the Java sets aside space in the stack frame for all the variables passed in and variables declared. So first, the main is called, which I don't have there. So main method is called. Main method, basically you just declare the array, which is that up there, and you set find me equal to 12, and then you say whatever the find index is, that is what is returned by the call to that one. So I'm saying return from the stack frame above. Stack frame above is basically call to this one. So from the main method, I haven't put the code here, you call this method. So from this, when you call this method, again stack frame is created. Anytime you call a method, a stack frame is created. So see, I said find index. So this is the stack frame. The stack frame is created for find index, and first thing it does, sets aside space for this and this, which is this array and find me. So I just put a star. Basically this is just to denote that it's a pointer. So if you followed my previous lecture, you would have seen that any reference type is a pointer. It's not a value. This guy is pointing to the same array that this guy is pointing. So this is a pointer. So array points to some memory location. Find me this, and from this find index, you're calling this method, the helper. So see, you call here helper. So sorry, I forgot to mention that when you start the program, none of this exists. When the main starts running, only this exists. None of this exists at that point. When main calls this part,
it's 10 o'clock.
Only this exists. These two, the one above, don't exist. I wrote it down before so that I can save time by not writing it during the video. So when this is called from main, only these two exist. None of this exists. From here, you call this guy, the helper. So that time, this stack index, this stack frame is created. These two don't exist at this point. This is created. So when this is called, start index is 0, end index is 7. When it comes and reaches here, mid index gets set to 3. Find is always 12. So find is 12. Mid index 3, like we saw earlier. From there, it comes here because the number you're looking for is bigger. So what happens is your start index gets set to 4 and get called again. So from here you call this again. From here, when you call this again, that is where one more stack frame gets created. So this doesn't exist. Now you have 1, 2, 3, 4 stack frames. This stack frame gets created. Again, it comes through here. Mid index gets set to 5. 12 is bigger than the number at mid index. Comes here, calls this again. When it calls this again, another stack frame gets created. See, I put the name of the method here, helper. So this stack frame gets created. And when you call this, again, start index gets incremented, 7, end index this. Mid index, when you get here, you calculate to 6. And then you see the number at the mid index is the number you're looking for. So you return mid index. So when you return this comes to this stack frame, because this guy returns whatever the previous call returns. So if you think in terms of stack frame, it's easier. So from this guy, it returns here, comes to this stack frame. So this goes away. So when it returns and comes here, this whole thing disappears. This guy returns, comes here. These two disappear, only this exists. This returns, comes here. All this is gone. You only have these two, and then from here, this gets done. And then after main exists, the whole program exists. So anytime you're solving a recursion-based problem, you have to think for this call, what do I have in the stack frame? And that makes it very easy to solve. Like if you think like at this point in time, this is what I have. So this is all I needed to cover. And again, like I said, there is a link in the description for more details on binary search. This is just to see how the recursive part of the code works. Thank you.